Everyone, so in the previous video we have discussed about the rules of the ray diagrams. In this video we will be looking into the ray diagrams finally. So here we have this first convex lens. So in the convex lens we have different positions of the object. So based on those different position of the objects we will be doing the ray diagrams. So first, in this case the object was at infinity. So the place of the object was at infinity. So it is far distant, so it is at infinity. We do not know where it is exactly, so it is at infinity. So from the infinity the light rays will always come in parallel. So in those mirrors also we have seen, when the object was placed at infinity, the ray diagrams or the light rays were coming parallel to the principal axis. So all these ray diagrams is coming parallel to the principal axis, and after refraction at this point, so after refraction all the light rays are meeting at one point, because we know that from the first rule we know that the light ray which comes parallel to the principal axis after refraction passes through focus. So all these rays are parallel, so they will pass through focus and eventually they will meet at this point. So in this point the image will be formed. Okay, so now we have to say that now we have to mention the position of the image. First we have to write the location of the object, and then second we have to write the position of the image, and we have to say the nature of the image. So in the first the object was placed at infinity, and where is the image located? The image is formed at focus or f2. The formation of image took place at f2. And what is the nature of the image? The image is real and inverted. So the nature of the image is real inverted. You remember one thing: the image which forms on the right hand side of the lens is real, and real images are inverted images. And the images that are formed in front of the lens, these are known as virtual images, and virtual images are erect in nature. So the image is formed on the right hand side at f2, so it is a real and inverted image. Okay, so this is the nature, and we also have learned the position of the image also. So next we will move to this second case. So in the first case the object was at infinity. In the second case we will consider the images. We are bringing the image closer towards the lens, and now the image is beyond 2f1, any point beyond 2f1. So previously it was at infinity, now we are bringing it closer, so now it is beyond 2f1, so at any point beyond f1. So one rule says that if a light ray goes parallel after refraction passes through focus. And another rule says that, the third rule says that if a light ray goes through optical center, it goes straight without being deviation or without being deviated. So there will not be any deviation and it will go straight. So these two light rays after refraction are meeting at this point. So this is the meeting point, and here the image will be formed. So the location of the object was beyond f2, beyond 2f1, and the location of the image is between f2 and 2f2. So it is in between these 2 points. And what is the nature of the image? The image nature is real and inverted. So because it is on the right hand side, you see the image is inverted and it is a real image. So in the third case we will move. So in this third case, previously it was on beyond 2f1, now it will be on 2f1. So we will apply two rules, as we were applying in the mirrors also. Two rules we have to apply to get the ray diagram. So first we will apply the first rule that says if a light ray moves parallel to the principal axis after reflection it passes through focus. And third rule says that if a light ray moves or passes through optical center, it goes straight without being deviated. So these two light rays are meeting at this point at 2f2. So if the object is placed at 2f1, the image will be formed at 2f2. Okay, so this image, the nature of this image is also real and inverted, because it is on the right hand side, and you can see it is an inverted image, and inverted images are real images. Okay, next we will move to the third case, where we will bring the object little closer. So previously it was at 2f1, now it is between 2f1 and f1. So the two rules will apply, the first rule and third rule. The first rule says if light ray goes straight or parallel to the principal axis after refraction, it moves or it passes through 2f2. f2 and that is focus. And another rule says that if a light ray goes through optical center, it goes straight without being deviated, and these two light rays are meeting at this point where it is meeting beyond 2f2. So the location of the object was between 2f1 and f1, and location of the image is beyond 2f2. And what is the nature of the image? It is real and inverted. And you see one thing, the size of the object is smaller in compared to the image, so the image we will write it is larger than the object. Okay. So in this case both are same, you see. So this size of the image is as same as object, and in this case it is smaller. Here you see the object size is this much and image size is smaller, so it is smaller in compared to the object. Here you see it is point size, or it is highly diminished or very small in nature. So in the next case we will see where the object is placed. Now the object is placed at f1 because previously it was placed between 2f1 and f1. Now we are bringing it closer, so it is placed at f1. So we will apply two rules, and the first rule says that if a light ray goes straight or parallel to the principal axis, after reflection it goes through focus. And another rule says that if a light ray goes through this two light rays, that is optical center, it goes straight without being deviated. So if you see these two lines, they will meet at some point, but we do not know where they will meet. They are moving in such a direction or in such a way that they will meet at one point, but it is not possible to meet in this stage. So they will meet at some point, we do not know where they will meet, so we have to consider this they will meet at infinity. So the position of the object was at f1, and the position of the image will be at infinity. And what will be the size? So if you see the size, that will be very large. So it is highly enlarged image. And what is the nature of the image? It is beyond this side, so it will be real and inverted image also. So in the next case we will see the position of the object. So now we will bring this black one is the object. So previously it was placed at f1, now we have brought it here. So now it is between optical center and f1. So we will apply the first rule. So after reflection it will go through f2, and we will apply the third rule. So it is going in this direction, so we will extend it backwards, and we find that the position of this, they will never meet at this in this way. So they are moving in different directions, so we have to extend it backwards, and they will meet at here. And if we extend one line, when we will make one line, we will find that the image is formed here. And you see the size of this object is smaller in compared to this one, so it is larger or highly enlarged image. And what is the nature? It is, you see, previously in all the 5 cases the image was found behind the lens, but it is forming in front of the lens, so it is a virtual and erect image. So this is all about the convex lens, the ray diagrams, all the 6 ray diagrams. And now we will move to the ray diagrams of concave lens. So in the concave lens, first we will place the object at infinity, as we place in all the cases. So from the infinity the light ray will come parallel to the principal axis, and after refraction, as we have already discussed in the previous video, that after refraction they diverges outward, so they can never meet. So we have to extend them backwards, and they will meet at f1. So the position of the object is in infinity, and what is the position of the image? It is formed at f1. And what is the nature of the image? So it is in front of the lens, so it is a virtual and erect image. And what is the size? So size will be very small or highly diminished in size. It's a point size image. So next in the case, so where we will place the object will be placed beyond 2f1, or anything between optical center and infinity. So anything between infinity and optical center, where we place, we may place here or we may place anywhere, the light ray will go straight, and if we meet the 2 points, we find that the image will be formed between optical center and focus. So in any case the image will be formed in this point between this f1 and optical center. So this is all about the lenses. So these are the very easy ray diagrams. I hope you give it a try, and if you find any kind of difficulties, you directly ask me. I am here to help you, and thank you for watching the video.